Hey everybody, welcome back to iHeartStats. Today we're going to talk about regression mainly, but the next two topics really fit together very closely. So I'm going to talk a little bit about correlation too today. So we're going to have a little introduction to the concepts behind regression and correlation. Mostly regression today, but I want you to think about correlation in this context, because when we come back to it in our next module, it'll make more sense if you've thought about it in relationship to regression. Okay? So now, before we actually get into regression proper, let's just go back to ANOVA for a second, because there's a clear relationship between the two. And since we've got ANOVA nailed at this point, I think if we go back and think about that for a second, it'll help us with our regression and how we're getting from one to the other. Okay? So you recall in ANOVA we had some kind of dependent variable that was quantitative over here, and then we had groups like group A, group B, group C, something like that, and then we had the scores on the dependent variable. We used IQ or something. Okay, we had the scores for everybody in group A, and then we had the scores for everybody in group B, something like that, and then we had the scores for everybody who was in group C. Okay, whatever they were. Okay, and then we tried to see the differences between these groups. So say this is the mean for this group, this is the mean for this group, and this is the mean for this group. Okay, and those were our categories that we were using to predict the dependent variable. Depending on what group you were in, we would expect a different value for your dependent variable. Okay. Well, this ordering of these categories doesn't mean anything, because they're just categories and there's nothing ordinal about them, right? But so they could be in any order. It doesn't make any difference. I could have just as well put the B's here and put the C's here, and put the A's here, and it would have looked like this instead. Okay, so this was the B's, this is the C's, this is the A's. Whatever, it doesn't make any difference. That ordering doesn't make any kind of intuitive sense. It doesn't have anything connected to it. But what if they actually were ordered? What if these were actually had values, and maybe they went from low to high, something like this, okay, and there was something about them was actually ordered? Then maybe it would look like this. We'd have this group here, we'd have this group here, and then we'd have this group here. Okay, and then all of a sudden, this line, this trend, actually starts to mean something. Whereas the trends here, there is no trend really. That's just showing which one's higher than the other. But this, we actually start to see something that's a trend. Okay, that's what we're talking. That's what when we're moving toward regression, we're moving in that way of thinking. Okay, so we have something down here that actually means something in terms of how they're ordered. All right. Now, supposing that we have a situation where there's order, but there's not just 3 categories, but there's an infinite number of categories. You could have a value anywhere along this scale. Then it might look something like this. I'm going to erase. So now it would look something like this, where we have data just any old where. It doesn't matter on this scale down here. You could have a data point anywhere. Doesn't matter. So there's an infinite number of categories, and so here's your data points. All right? And then what we're going to try to do is, for this trend line, we're actually going to plot a line that goes right through the point somehow. That's the best fit line among those data points. It's the line that's most representative of those points. But now we can have data just any old place and along these values here, and that's what we're going to do with regression. Placing that line, figuring out where that line is, where that best line is, that's what regression and correlation is really all about. Okay? In correlation, we're interested in how close the data points are to the line. Okay? So in this case, my data points are pretty darn close to my line. If it was a perfect correlation, they'd all be right on the line, like that. Perfectly on the line, okay? That's a perfect correlation. But supposing that it weren't perfect and it looked a little bit different. I'll just take this out real quick. Okay. And a correlation that's not so hot would be something like this. But there's still, the best line is still the exact same line that I had before. No difference in the line at all. But now the data points are farther away from the line. And so now I don't have a good correlation. That's what correlation is telling us, is how closely those things are packed into the line. Okay? All right. But regression, we really have a different kind of a question. We have something different that we're trying to find out. We're not as concerned about how close they are to the line. We kind of are. We'll get to that later. But we have a more fundamental question that we're trying to figure out when we're doing regression. The question that we really want to know when we're doing regression is, what is the slope of that line? How steep is that line? Okay? If we know that, okay, then we're going to know something about the relationship between our dependent variable and our independent variable down here. Okay? We're going to know that we're going to know two things that are going to tell us something about the effect of this independent variable on this dependent variable, and that's the run and the rise of the line. So for however much we run across this way, how much higher are we going to get? What kind of a rise are we going to get in the line? And that's really going to tell us, if we make a change in the independent variable, what kind of a change in the dependent variable are we going to expect to see? So this run is the change in the independent variable. And then if we move that much on the independent variable, how much are we going to go up here on the dependent variable? Okay, the rise, right? So that's what we're trying to figure out, is that relationship. Example, supposing that the independent variable is education and the dependent variable is income. All right, so my hypothesis that I'm going to be working with, the idea is that if you have more education, you're going to make more money, right? And so I have data points that are each individual person's education level. Maybe I measure it in years of education. And then I have their income, how much money they make each year. All right, so that's what each of these data points are, somebody's education level and income level. And there's a relationship here, a positive relationship. So as you have more education, you get more income, okay? And the slope of this line is going to tell me, for every one additional year of education, how much more money am I going to make? That's the relationship that we're getting with the slope of the line in the regression model, okay? Now there's a second question that you get answered with regression too, and that's not usually as important, but nevertheless, you do get to answer that question, and that's, where does this line cross this zero axis? So this is like zero education and zero income here, but it actually crosses higher than this, higher than zero. So that tells me, if I have no years of education, how much income do I expect to make? So that's called the y-intercept. So this is called the y-axis, and so that's the intercept, and it tells us how much money, or how much of the dependent variable we're going to have when the independent variable is at zero. Okay? Now, you might recall that interval level data has an arbitrary 0 point. So it doesn't necessarily tell us that much in an interval level setting, but nevertheless, it's something that comes out of the calculation. We'll talk a little bit more about that later on. Okay? All right, so those are two things that you get from the regression model, the slope and the intercept. Okay? But the third thing that you get, from the analysis, and that's going to be important to us, is, does the slope of that line, is it significantly different from zero? That's going to be our fundamental statistical question as we're doing regression models. Supposing that we have a couple of different relationships. So let's suppose we have a relationship like this. There's a slope. It's got a pretty high slope. So a relatively small amount of movement in the independent variable produces quite a bit of change in the dependent variable. Okay? But maybe the line looks more like this. Okay? Now it's going uphill, but just barely. Okay? And that might not be that different from zero. If a slope of a line is zero, that means it doesn't matter where you are on the independent variable, you still have the same dependent variable. So if this was education and income, this would mean that education does not affect income, Okay, that's not true, but in the real world, but nevertheless, you could find relationships like that. And so the question is going to be, is the slope of this line significantly different from 0? And we're going to figure that out with our regression model. I just want to point out one other thing with these regression models, and that the lines don't always go uphill. They can also go downhill, a negative slope. You can get a negative value for your slope. And that means for every increase in the dependent variable, or in the independent variable, for every increase, that this dependent variable decreases, right? Okay, so there's a lot of things that have that kind of negative relationship instead of a positive relationship. So you got to look out for that so you know that it's going downhill. One variable is going downhill as a result of the other one going uphill.